Hello friends, how are you? Welcome to Kumba Science Academy. Today we will start our lecture regarding the 12th standard chapter. Okay, so what is that 12th standard chapter? The chapter is Logic of Mathematics 1. Most importantly, in this chapter is actually new for all of the students. Within this chapter, we will see few interesting parameters. Okay, so most important parameter is a truth value, or what we can say, the truth or false, true or false table. So this topic is quite new to all of you, and I know this topic is quite out of your normal mathematics. Okay, so it's a most importantly is regards to the statements. Okay, now you never think of these statements in deep. Okay, the way you will think within this chapter. So first come first, what do you mean by statement, sir? The statement, I would like to write it as a statement. Okay, so statement means what? So within this logic concept or the chapter, the statement has most important. Okay, most of the importance are for the statements. So whenever we are doing this kind of statement things, so at that time we never thought about whether which kind of sentence can be statement. Okay, so the sentence and statements, these two different things. Okay, but they combines at one particular parameter. So what is that parameter? The statement is the declarative sentence. Okay, listen carefully. The statement is what? The declarative sentence, and which has true or false value, okay, at once. So out of this true and false, we can choose only one value for that statement. Okay, so how we can arrange this? Okay, the statement is, it is okay, most importantly it is declarative sentence. And another most important parameter is what? It is either true or false. It is either true or false. Okay, now it is either true or false, and nor both. Okay, so it should be have one particular value, it should be true or false. Now how to understand? Again with example. For example, I am so much busy. Will it be statement? No, it's not a statement. It's giving information which is quite not defined. It's not defined statement. Okay, sentence. So that's within the sentence we should have information which can be get justified. Okay, listen carefully. Within the sentence we should have some information which can get justified. Okay, so justification means what? It should have particular defined value. Again listen carefully. It should have defined value. Value means what? It should have defined particular terms. Okay, for example, sun sets in west. Is this correct? But the sets means what? Sun is getting set at particular direction. So that direction and the sun and the process. Okay, so sun is processing something. What is that sun's process? Sun process is what? It is setting. Where? It should set in west, but it is setting in east as per my sentence. So therefore this sentence contains some information again which can be get justified, and due to which we can say that given sentence is what? Statement. Now next factor, whether it is true or false. Yes, of course it is false. Sun rises in east and sun sets in west. So common sensely this statement is what? False. So on this basis we can have our parameters. Now again another most important. So India's capital is Delhi, that is true, and Maharashtra's capital is Nagpur. Now this is false. Are you getting this kind of things? So we need to think within this pattern. Now another most important parameter, this was regarding statement. Okay, the statement is done. Now next part is what? There are two types of statements. One statement is simple statement, another statement is compound statement. So I would like to first of all define that what do you mean by simple statement. So simple statement first. Simple statement. Okay. Now here we have some interesting parameter. Okay. The simple statement has its own variation. So what is that variation? It's not a variation, it's a defined particular quantity. Okay. It cannot be divided in more statements. What? It cannot divide in more statement. That statement is called as simple statement. Okay. Listen carefully once again. The statement which cannot get divided, or what we can say, we cannot separate in another two statements. Okay, that statement is called as simple statement. Okay, it cannot get divided. Okay, and another one pattern is compound statement. Okay, that's another very important parameter. It is combination of more than one statement. It is combination of more than one statements. So we can have this. These are the two types of statements: fundamental, simple statement, compound statements. Okay, so compound statement. So these two statement types are done. Now hope we are going so kindly fast. Okay, so I would like to reduce my speed first. Sir, why and how do we require this logic in our day-to-day mathematics? So whenever we have particular equations and these particular equations are true or false and given quantities are right or wrong, what we can say, to check whether the problem is solved properly or not, we are not able to do it from starting point. Okay, so at that time what we look at the end point, and we pick up those equations and simply apply the logic. And due to this kind of logic concept, we can easily identify whether given whatever those reasons and the equations are right or wrong. Okay, is kindly equal to what we can say, it is equivalence to our chapter in that was like dimensional analysis, which we performed in our 11th standard. Okay, the dimensional analysis of physics. Okay, it is kindly similar to that. Okay, so this chapter gives us hint regarding those complex mathematical equations which are true or false. Okay, those equations are possible or not. So we need to take right hand, we need to take left hand, match those logical things, and we can say simply prove that whether this is given equations are true or false. So on that basis we can apply this topic. This topic was developed by, it was developed way away in history, but nowadays it is applicable, and so many different mathematicians are arguing on this thing whether it is mathematical part or not. But as per the ancient saying that mathematics is a language of logic. Okay, it's a language of logic. So commonly whatever the mathematics we are dealing nowadays, that is simply dealing with this logic, and each and every equation has its own statement. Okay, whether it is true or false, that's another factor that we will check in future. But the mathematical logic is most important. Okay, in many different aspects. Okay, it was used in many fields. Okay, this logical reasoning and logic chapter was used in many fields, okay, especially computing, electronics, and what we can say, uh, thief identification, whether someone is saying true or false, okay, whether their statements are true or false, okay. So for that kind of purposes also these people are using this mathematical logic. So now come to point. So we are applying this chapter, and we can apply this chapter in different fields. What is the most important parameter we need to understand? How we can study this logic in mathematical manner. So again, whenever the mathematics comes, there are few symbols are coming, okay, with the mathematics. So mathematics word carries few symbol, not few symbols, so many few symbols, and so many logic with it. So we need to follow it. How to follow it? First of all, try to understand how exactly these statements are possibly written. So compound statements can be written in different formats, okay, and those formats are called as connectives, okay. So compound statements can be written in form of connectives. Now our next topic is what? Connectives, okay. Our next topic is connectives. So connectives are mainly applicable. So how we can connect two statements? So common sense connectives are regarding what? Compound statements. These are not regarding what we can say. These are simply identified on the basis of the how exactly statements are joined together. So two statements, whenever we want to make one particular statement, at that time we require some connectives. So what are those connectives? In our grammar basis, if you saw, so we use and, or, then, if and only, and if and only if, okay, if then. So this kind of connectives we commonly use in our day-to-day grammar, okay, and that's how our language is developed. Now within the mathematics term, we have these connectives and we have different names of these connectives, okay. So first one is what? Conjunction, okay. So first connective is okay. So first connective is conjunction. The conjunction is mainly indicated by what? It represents our grammatical connective and, okay, grammatical connective and mathematically how we can represent two statements. If there is a statement P and if there is a statement Q, we can represent this by this arrow, okay, and so this symbol represents conjunction, okay, conjunction of what? P, statement P and statement Q, okay. So simple statement can be represented as P, Q, R, S. So we can give them name. So different names. So most commonly using P and Q, okay. Don't know how we are using this P and Q. So I think we got bored with this A and B, X and Y. So nowadays we are using this P and Q. Nowadays means what? From last 200 years, 2 to 300 years, we were using this P and Q. In different books we saw this kind of symbols. So these are the only symbols. There is no particular meaning for them. This is only symbol for one particular statement, okay. We need to again signify whether which statement is which, okay. So if this is P, so P is standing for some statement and Q is standing for another statement, and if these two statements have got combined by particular another statement, then we need to use this conjunctions, okay, sorry, connectives. Now next connective is what? Now next connective is what? Our conditional. So next is what? Conditional. Sorry, next connective is what? Disjunction. So this is conjunction, next one is disjunction. I was in hurry, so let me slow down. So this disjunction, so I write it separately kind of over here. Why? Because here is what? Conjunction, and here is what? Disjunction. So disjunction simply indicates that two statements are together but they don't have any kind of relation with each other. they have relation, but they are not have this kind of dependency. Okay, so I'm using my words very carefully here. Why? Because this is represented by grammatical or. Okay, this was represented in grammar or, and the symbolically P or Q. This represents or, means what? Disjunction. What? Disjunction. Now we have statements. Okay, so which kind of statements, whether it is true or false? We have two statements. First statement is what? Moon is white. Okay, moon is white or moon is black. So this or, moon is white or moon is black. So this or we can use within that. So what is P? Moon is white. And what is Q? Moon is black. And that was connected by or. So moon is white or moon is black. So I am not writing all those statements. Okay, so we are just about to see how it exactly works. Okay, not exactly, tentatively how it works. Now next one is, this was regarding disjunction. Now next connective is third, what? Conditional. Okay, so conditional simply represents what? Conditional is nothing but if, then. Okay, I am specifically writing this if then. Okay, so P implies Q. P implies Q. Now what should be the statements in statement form? How we can use this? Okay, if sky looks cloudy, then today there is rain. Okay, so in this pattern we can use this implication. Okay, another one is, okay, if you study hard, you will be succeeded. So that is again implication. So implication means this P happens, then only Q is true. Listen carefully. If P is true, then Q is true. If P is false, then Q is false. Understood? So on that basis we can use this. So I will go to that truth table and truth value. First of all, understood how exactly this conjunction, disjunction, conditional, and then another one is biconditional. So within this pattern, Q is depending on this P. P is not depending on Q. Listen carefully. Okay, if P happens, Q possibly happens. Okay, that process possibly happens. But Q happens, it does not necessary that P happens. Understood? Okay. Now the biconditional is opposite to this, not opposite, it has some additional quantity. So as per the name suggests, biconditional. Okay, if and only if. What is that? If and only if. So I am writing in shortcut. Okay, you will see in the textbook that different kind of examples are there. What is that? If and only if means P happens, Q happens, Q happens, P will definitely happen. Understood? Okay. So these two are interrelated or interdependency shows. Okay. So if P happens, then commonly Q is also possible. Q is possible, then definitely P is also possible. So these two are related. Okay, so if one process is possible, then another is not possible. One process is happening, then commonly another process is also happening. It's like you are using mobile, then common sense you are using or you are playing PUBG. If you are playing PUBG, then common sense you are using mobile. Okay, that's odd example, but quite similar, familiar to you. Now within this case, the biconditional statement, we can see this pattern. Okay, it's very interesting. Okay, this chapter is very interesting if you look at it properly. Though it looks odd in terms of mathematics, we are studying grammar. Okay, so to study mathematics, we need to study grammar properly. We should be good at grammar level. Now next is what? Fifth one. So in books and in different books also they have given this connectives, but this next which we will study, that is what negation. I don't think so that is negation. Negation is connective. It is a part of that statement, or what we can say another pattern of that statement. Okay, so one statement is given. Okay, that statement's negation if we form, so we are using not. Okay, I am going to school, and what is the negation of that statement? I am not going to school. That's it. Today I am not going to school. If the initial statement was today I am going to school, and the negation of that given statement is what? Today I am not going to school. Understood? So in that pattern, that negation does not have this kind of connectives. Okay, there are no two statements. If there are two statements, then we need to make negation of those two statements and again combine them. Understood? Okay, that's the most complicated part, and in most of the exams they are asking this negation. Okay, from last so many years, I don't know, means from my 12th standard I'm studying this chapter. Okay, and initially how many of them had, I don't know, but I think it was from last 20 to 30 years within the 12th standard of the HSC board. Okay, and different standards I didn't saw this kind of chapter. Okay, so especially ICSC board, they don't have logic chapter. CBSE board, they don't have logic chapter. Okay, and HSC board we have. So we are thankful to our HSC board that they are giving us very important and a huge chapter. Especially our 12th standard means HSC board's 12 standards, this mathematics and 11th standard mathematics is having its own standard. Okay, it's not like the ICC board and what we can say. ICC board has its own standards, but still we are comparable with the CBSE and HSC, this ICC board. So ICC is not ICC, actually it's ISC board. Within those boards, we have different tough questions. Okay, but those tough questions are simplified formed, and they gave us within these 12 standard books. Okay, they gave us in solved format. Okay, so this new syllabus also I am expecting this new pattern also contain this kind of questions which are already solved, and within this new topic or new syllabus they have included so many interesting things which are not present in ISC board and CBSE board. That's how we need to thankful to our HSC board mathematics especially. Okay, so they are included these very new terms. Okay, and those are very helpful to study mathematics in depth. Okay, so that definitely important point. So next, negation. Okay, so negation, it is simple. Okay, so it is using simply we are using not or NOUGHT not. Okay, those also initially they had this in grammar, now they using NOT not. Okay, both are pronunciation same lagbhag. Now next step, now P, negation is negation of P. So P negation is indicated by this step. So it is equivalent to. So negation is done. So up to this, these are the conjunction, disjunction, conditional, biconditional, negation. Okay, I will repeat: conjunction, disjunction, conditional, biconditional, negation. These 5 important connectives we just saw, not in depth. Okay, not in depth. Now we will see truth value. Okay, most important part. What is that? Truth value. So how to indicate this truth value? So indicating the truth value, let's see. So most another important part, truth value. Truth value. So truth value, what it indicates, sir? So it indicates whether the given statement is true or false. Okay, so it can be either true or false. So we need to understand how exactly it works. If statement is true, if statement is true, then truth value is capital T. Okay, so I am giving the comma. The truth value is T. If statement is false, common sense, then truth value is F. Okay, so these are the symbols. Truth value means what? Symbols we are introducing over there. Okay, so this was the truth value concept. If our statement is true, then we have its if our statement is true, its truth value is T. If our statement is false, the truth value is false. So that's it. That's it, nothing else. If they ask you what is the truth value of the given compound statement, we need to find out. And how to find out? Okay, for that purpose we have next important section, that is called as the truth table for conjunction, disjunction, okay, then conditional, biconditional, negation. For all these 5 connectives, we have one particular truth table. Okay, so this indicates in different cases, in different scenarios, how we can have the truth value. Okay, are you getting what I am saying? Yes. What is that? We have truth table for different cases of these individual connectives. Okay, within which we can identify exactly how we can find the truth value. So that whole table contains different cases. Okay, and within those different cases we can identify what should be our suitable value for the given statement. Hope I am clear. Okay, now next we need to move on those what truth table. We will discuss the truth table for our conjunction, disjunction, conditional, biconditional and negation. So first, truth table for truth table, okay, or what we can say truth values of different situations. Okay, so truth table first for conjunction, okay, so what is that conjunction? P and Q. Okay, so P and Q are these are two statements. So P, here is Q. So how many possible values this P and Q are possible? Okay, the first is what? If our statement is true and Q statement is true. Our statement P is false, Q is true. Both are false, okay, and both are true. So in this way we need to manage, okay, how many possible combinations are there. Okay, so are you getting? So possible combinations we need to find out within these two quantities. Okay, how they can arrange. So each has one true, one false, one true, one false. Again, so again making their combination, this will leads to us what? 2 raised to n. How much? 2 raised to n. So for this quantity we has how much values? 4. So T, T, F, F. I am managing this T, F, T, F. There is no different reason. Okay, there is only one simple step. Okay, to remember T, T, F, F. Okay, for that purpose we are writing it like this. And again here T, F, T, F. Why? Because this should not again get similar values. So no value is repeated. This is unique combination, this is also unique and this is also unique combination. Okay, so on that basis we are making this combination. So this is most important part of this table. Now what is another important part? P and Q. For what? P and Q. Now this is very simple pattern again. If you add, so instead of adding I would like to say multiply. Okay, how we will multiply? If you consider this as a 1 and this as a 0, sorry, this as a 1, if T stand for 1 and F is stand for 0, okay, let's consider, okay, that's not the case. The case is different. This is true, this is true, this is true, this is false, this is false, this is true, this is false, this is false. So this is true and false only, nothing else. But I am just saying to consider it, to understand this AND table. This is nothing but AND table. Okay, this represents AND grammatically. What? Grammatically this represents AND. Okay, and mathematical terms, in terms of logic, we are calling it as a conjunction. So in this case, if we multiply this 1, so if it is stand for 1, this is 1, so 1 multiplies 1 will give you 1, which is nothing but 1 stand for 2. Okay, so I am giving you shortcut. This is not my shortcut, this is usually used by different, okay, so teachers also. So this is commonly used. Okay, now again T multiplies to F means what? 1 multiplies to 0 will get 0, means what? False. So false stands for 0. So 1 into 0, 0. Again 0 into 1, 0. 0 into 0, what? 0. Nothing else. 0 into 0, 0. So that's how we simply have the value. What is that? So this is simply indicating the multiplication. If you again, I would like to suggest you to perform this task. Okay. So and if you are taking this P as 1, 1, 0, 0, and this Q as 0, sorry, 1, 0, 1, 0. Okay. And again P and Q, you will get simple values. What is that? 1 into 1, so and represents multiplication. So as I said, okay, to keep it in mind, okay, just check the spelling. Multiplication might be possibly wrong. So that's not the important part. Just keep in your mind that you are using the multiplication process in terms of AND, means what? In terms of conjunction. So what you will get? 1 into 1, 1. 1 into 0, 0, 0 into 1, 0. How it is 1, 0, and again 0. So in this manner I am writing this table. Okay. So you can simply take this chart. Okay. So understood. So just keep in mind. Okay. So multiplication we are doing within the case of this conjunction. Okay. That's how I remember this graph at my 12th standard. Okay, so now I would like to suggest you to do so. Now next step, next truth table for this disjunction. Okay, so it was conjunction, next step is disjunction. Means what? P or Q represents or in statement. So again statement is P, Q. Okay, so here is what? T, T, F, F, T, F, T, F. Hope so you are getting. Now within this steps, what we are having? We are having very interesting quantity. Here we have multiplied. Here we need to add. Okay, as considering T as a 1 and F as a 0. Why I am telling you 1, 0 in this pattern? Because in semiconductor chapter of physics, or what we can say in semiconductor chapter physics, yes. So within that chapter, that's the new process they have included, logic gates. That's a very interesting chapter, and within that topic we have these inputs of digital, okay, gates. So those gates require this AND gate, OR gate, NAND gate, okay, NOR gate. So within these gates we need to do the same process of this logic. So we need to find out how many there are possible outcomes. So due to which I am telling you this process. Okay. So then this is again applicable over there also. Most of the students are get jumbled. I mean, how to apply this? So there is no different, or the alien science. This very simple one. Okay. This just look at it as I am saying and just follow these steps. So T addition of 1 plus 1 again. So addition of 1 plus 1, you will say how much? 2, common sense. But here we need to say it as a true. Means what? 1 only. So this is nothing but true. But addition of 1 plus 0, how much? 1, this is true. Addition of 0 plus 1, how much? 1, which is true. Addition of 0 plus 0, common sense, 0, which is false. And that's how this interesting what I'm saying, interesting topic is. So up to this disjunction done, conjunction done. Now next step is what? For we need to apply third one. What is that third? That is one conjunction. Not what is that third one? Conditional. Sorry, not conjunction. Conditional. Conditional, what it represents? It's again very interesting pattern. Conditional as a dependency, as I said earlier. So what is that dependency? Dependency simply indicates that the P is depending on Q. Now Q is depending on P. So I would like to write it first. What is that? What is this conditional means? P implies Q, and this is nothing but if then. Okay, I am representing this like this, so you can have your own terms. P, make a chart of this, okay, and put it on your wall or the where you want to put it. But this will be useful. This chapter is asked from last 10 to 20 years for this 5 to 7 marks in each exam of 12th standard. So that's how this chapter is most important. But people are thinking this chapter is quite fuzzy, so many students are not doing it properly, and most of the time what happens, this chapter is easy, we can perform it, and they do different kind of mistakes in their exam. So don't do it, okay? So please prepare it properly. This chapter is easy, but this is not that easy as you're thinking, okay? So there are so many different variations, and this is totally regarding your mind setup. If you are disturbed while solving the question, there are 99% of chance that you will get wrong answer, okay? So you need to be very stable while solving the simple questions of these chapters, okay? So P implies Q. So again T, T, F, F, T, F, T, F, what it implies, okay? Most importantly, T, 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 F, okay. So no, without any fuzzy process, let's simply solve it. How we can solve it? If you study, you will get pass. True? True. If you study, you will get pass in the exam. Yes, true. So your passing process is depending on your study process, okay, in first case. Now most of the students saying that without study we are getting pass from last so many years, and still we came to science, and again we will get pass without any hard study. So the next statement is true for them. The next to next, this statement is also simple. You study and you get fail, which is false. It's not possible. Okay, if you study hard, definitely you will get a marks. At least you will get some marks. Okay, it's not possible to get fail. Okay, it's not possible case. So it's false. Okay, that's simple statement. Again, if you do not study and still you are getting pass, what do you think? What should be over here? You know, but as per this statement requirement, is this true statement? If you do not study hard and you are still getting pass, yes, of course it is possible. 35 marks required to get pass. Okay, so you need not to be get study hard. So this statement is true. Okay, are you getting this step? How it is working? Again, if you do not study, you do not get pass. Common sense. If you do not study, you do not get pass. This statement is also true. These are the statements. These are not the cases. Okay, the statements with the different cases, but they are saying the statement. If you got the statement that if you study hard If you do not study hard, you will get failed. So in some exams it is possible. Okay, so therefore what this statement is true. Okay, in Marathi we used to say this. Okay, so I learned through Marathi medium, and up to the science. Okay, so science we did it in English medium, but we used to learn all these processes through our own language. So mother tongue, through our mother tongue we used to study. So there was one sentence we used to apply for this conditional. What was that statement? अभ्यास केला तर पास होशील. ओके, अभ्यास केला पास झाला, अभ्यास नाही केला नापास झाला. बरोबर आहे. अभ्यास केला नापास झाला, शक्य आहे का? नाही शक्य. अभ्यास केलाय नापास झालाय, होऊ शकतं का? नाही होऊ शकत. फॉल्स. अभ्यास नाही केला तरी पास झाला, कॉपी केली पास झाला, शक्य आहे. कॉपी केली पास झाला, शक्य आहे. शक्य आहे, दिस अ पॉसिबल केस. अभ्यास नाही केला नापास झाला, तेही शक्य आहे. सो विच इज ट्रू. अंडरस्टूड? सो I hope you understood Marathi. Okay, so this is the statement which I apply every time to teach this conditional state. Now next step, biconditional, which is very interesting. And again in this case, again if you don't understand for this conditional state, okay, just simply think that Q is depending on P. P is not depending on Q. Are you getting? So P is depending on Q. It's not true. What is the true thing? Q is depending on only P. P is independent. P is what? Independent. If both are not depending on each other, then there should not be any kind of statement. Okay, one of these two, okay, should depend on each other. One of, at least one. Okay, so therefore what is the possible case to understand is, okay, P is happening, Q is happening. If P is what? Happening, Q is not happening. Q is not happening, which is false. If P is not happening, Q is happening, which is true. Okay, understood? This is the most important part. So this dependency looks over here. If you look at it properly, so P is not happening, common sense Q is also not happening. So what is that happening, sir? The process is not happening. Understood? So P process is not happening, Q process is not happening, common sense true. P process is not happening, T process is happening. P process is happening, Q process is happening. Understood? So this is true. So P is happening, Q is not happening, which is wrong. Understood? Which is false. So it is false. If P is happening, P is happening, Q is happening, common sense, it is true. Understood? So on that basis you can remind, or if you don't understand, if you forget how to understand this table, you can simply use that statement which I told you earlier. Okay, आपने पढ़ाई की तो आप पास हो जाओगे. Okay, you can apply that statement or apply the cases. Okay, definitely you will understand. In Marathi, अभ्यास केला पास झाला. So what is Q? पास झाला. What is P? अभ्यास केला. And in Hindi, पढ़ाई की पास हो जाओगे. So what is P? पढ़ाई की. What is Q? पास हो गए. Understood? So apply this statement, definitely you will get the answer. And this statement is very simple. Okay. Fourth one. What is that fourth one? Biconditional. Biconditional says something like this: P implies Q, and if and only if. It's not if then, it's if and only if. If P is happening, Q is happening. If Q is happening, P is happening. It's like, okay, so I will give one different and awkward example. Okay, not that awkward. Okay, it's related to you people. So this is T, T, F, F, T, F, T, F. Okay, that's correct. Now next statement. You have mobile, definitely you will play PUBG. True? Okay. If you have mobile, then you will play PUBG. Okay, that's correct. True. If you have mobile and you are not playing PUBG, common sense. Nowadays it's not possible. Every 12th standard boy is trying to play PUBG. So it's false. Okay. Okay, it's happening. It's not the accurate case. I'm just telling you the way I remember. Okay. If you don't have mobile and still you are playing PUBG, which is false, it simply indicating the false statement. You are playing PUBG with another phone, mobile phone. That indicates you have phone, and you have phone and you are saying that you don't have phone. Okay, so mobile. So which is false. Again, this is false. You don't have mobile. You are not playing PUBG. Common sense. It is true. Okay. So that awkward example with you. So we done with this. Okay, not yet. We need to again put this negation also. So I am putting this negation truth table over here. So hope you understood this huge and interesting pattern of this truth table. Okay, so whenever you are applying this truth table, use multiplication. Whenever you are applying this disjunction truth table or the truth values, apply addition process of 1 0. So here it is what? 1 0. So 1 0. Remember like this. Okay, you can remember like this. Again here 1 0. You can memorize it like this, and here you can use that example of study pass. Okay, study fail false. Okay, again here what? If and only if. Okay, so you can use this. So when the two values are true, then only it is true. When two values are false, then it is true. When the mismatch is not possible, so all the values are false. So T F F T, and it is what? T F T T. It is what? Truth value of this. T T T F T F F F. Okay, very interesting. Do not mug up. Please don't rectify it. What we can say, इसको दिमाग में मत लेके घूमो कि हम ये कर सकते हैं. इसको सिर्फ इतना ही दिमाग में रखो कि इसको किस तरीके से हम समझ सकते हैं. Okay, try to understand it. Try to what we can say, derive it. Okay, on your own basis. Take a different kind of examples. Make your own examples. Okay, which can be applicable. But do not rectify it. Again and again I am saying, please do not memorize it. It is not possible case to memorize. Okay, why? Because as we move further, okay, sooner or later we will find it is difficult. Okay, so please, I am saying please do not rectify it. So hope so you are clear up to this. Now let's move to one simple part. What is that? Negation. So we can complete the negation over here only. Okay, so fifth one, negation. Okay, at a corner, hope you will get it. So what is that? P. If P is true, so negation of P is false. Okay, understood? If P is false, negation of P will be true. Hope you will get it. Okay, I am not putting square brackets for this. Hope you will get how exactly these are connected to each other. Now we will solve the exercise in next series. Next step we will solve the exercise. Before going to exercise, I would like to give some hints regarding how this complicated chapter is. We need to again look at within the chapter how chapter is working on, and they have given us few solved examples. If we solve the solved examples, we will definitely solve the exercise. Okay, so for this lecture I would like to stop over here. In next lecture I will take our exercise. Thank you.